Hi, welcome to this first episode on comparison between Excel and R. I'll be giving you tutorials in this series of videos showing you how you can accomplish a given task both within Excel and R. Today's episode is I am going to start with this dataset. You see, I have opened my screen is divided into two parts. I have part on Excel. I have a dataset opened in Excel. You see, I have a dataset with column 17 columns. The very similar dataset is as well opened in R. This is our studio interface. What are we going to do now? I'm going to introduce you a new task we are going to accomplish today. Is about transforming our dataset from wide format to long format. What do I mean? I'm going to refer to a term initiated by Hado Wickham. Hado Wickham is a data scientist from RStudio. He referred to a dataset that is not tidy, a dataset to be dealt with is to have a tidy format. A tidy format is a column should occupy a single variable, and observations or data point should be on rows. A single data point should occupy a single cell on row. You see here we have column name, country code. Here we have a single country code 900. This 900 should be pointing out a single data point. We should not have a data point like this 900 comma 800. This is not a tidy dataset. A tidy dataset should consist of a single value per row, a single column per column, a single variable per column. So what we have as issue with our dataset here, a column country code has no issue, column country name has no issue, but if we come to the third column being 1950 to 1955, this is not a good variable name. This is a compressed data set. There is a time period combined with data observation, data observed. Let me introduce you to the background of this data set. Let me show you what it's all about. Excuse me, it's E0F. It's a dataset within the package WPP 2019. It's a dataset from United Nations. It's a time series dataset about life expectancy worldwide. All the countries within the world, their life expectancy have been captured since 1950 until 2020. This data set, the time period here has been put on column headers. While this time period 1950-1955 should be should be data point as they are, not variable, not a separate variable. This 1950 until 1955 until 1960 should not be considered as a separate variable. They should be forming a single variable, being time or period, and the observation here should be should contain another variable. Maybe we can call it life expectancy or anything else. But this case of data storage, it's for sake of reducing the space occupied by a dataset. It's a compressed dataset. It is done for the case of optimizing space. But for dealing with this dataset, when it comes to data wrangling or data analysis, it's quite hard to deal with this dataset. You need to do a preliminary transformation on this dataset for it to be analyzed. This is what we are going to do both in R and do it in Excel. I'm going to start with Excel. I'm going to show you how you can approach this task at hand in Excel. Many of you might not be aware of how to transform data from wide format. This is in wide format. I'm going to transform it in long format. How can we do it? It's a bit tricky. I'm going to use a shortcut. Let me write in RStudio a shortcut Alt plus D plus P. Alt plus D plus P. Let me do it. Alt plus D plus P. Excuse me. Alt D P. You see, I open a pivot table and pivot chart wizard. In this pivot table and pivot chart wizard, it is where I am going to transform my dataset. By default, it is ticked Microsoft Excel list and or database. I'm going to click on multiple consolidation ranges, only that, and click on next. Here, this wizard is asking me how many page fields do you want. I'm going to click on I will create the page fields. Then I click on next. It asks me where are the worksheet ranges that you want to consolidate. The worksheet ranges I want to consolidate, I'm going to start from the second column, being the country name. Then I am going to go to select all the way to the right, except the last column. You see, I remove the last column. Then I select all the way down. I select the whole range, except the first column and the last column. Then I click on next. After clicking on next, it asks me where do you want to put the pivot table report. It's on a new sheet, no problem with that. I click on finish. After clicking on finish, you see a new worksheet is opened and having a pivot table in it. I go all the way down to the grand total. You know already a pivot table should have a grand total. I go to the last grand total. I double click it in the grand total, the last grand total. If you double click in the last grand total, it brings a new table. Let me expand these columns. It brings a new table. You see, I have row here, I have column here, I have value here. Let me change this row here and name it country name. Then the next column, let me call it period. If I may say, it's time period. Then the last is, let me call it life expectancy. expectancy bracket percentage, it's in percentage. Then this is my data set in long format. You see this data set, you see I am, the last row is on 3487. let me go on the original data set. The last row was on 250. You see the long format has created many rows. Initial dataset had 249, while the transformed dataset is now having rows more than 3000 rows. You see, these are the steps in which you can take to transform your dataset from wider format to the long format. In that case, you can proceed with your data analysis. Let me copy this whole data set and show you. I may come here to the sheet 4 and paste this data set. I'm going to design this table and remove all the duplicates. Which duplicates I'm going to remove? I'm going to remove the country name. Okay. Excuse me. Okay. I'm going to remove country name, all duplicated country names. Then I remain with only the countries without duplicates. After this, I am going to select top 10. Let me select top 10 of this data set, and I am going to plot to create a simple chart of this data set. I'm going to create a simple chart of this data set like this one. You see, I have now a data set which is good to be presented. Let me rearrange this data set from, let me say, from largest to smallest. You see, we have our the countries with the highest life expectancy is Norway. The last country on the list of top 10s is the United States of America. You see, this is a simple chart created from this raw data set, transformed from we have transformed this raw data set and came up with a pivot table like this one, and we resulted into a long format, a long format data set like this one, ready to be analyzed, which resulted in this chart. But having this raw data set, it's quite difficult to analyze this wide format. Let me now embark after this short break. I'm going to show you how you can do this in R. Welcome back in R. This is R Studio. Let me close this one. I'm going to close everything and show you how you can approach that task in R. We first load the tidyverse package. This is an ecosystem of packages for data analysis. Let me say like that. Then I load the package we used, package for data, package for UN datasets. We load these two packages. Let me remove the output from the R Markdown dataset to be printed in console. After loading the data, I load the data set being this one E0F. After doing so, this is deprecated. I move it. This is the data set we have loaded both in Excel and R. Let me show you how we tidy the data set. How do we tidy the data set? E0F. This is the raw data set. This is the raw data set. We are going to turn it from wide. This is in wide format. We are going to turn it from wide format to long format like we did in Excel. How do we do it? I start with the data set. And use pivot table, pivot longer. There is a function named pivot longer. If you want to know more about this function, you can start with a question mark followed by the name of the function. It is the function from package tidyr. This tidyr is part of tidyverse. That's why I have not loaded tidyr, but still pivot longer is accessible because I have initially loaded the tidyverse package. Then this pivot longer works how? We specify the columns. We want to turn into longer. We want it to transform. How do we specify them? We can use different ways to specify the columns to be transformed, but my today's case, I'm going to use 1950 until 1955, and I use a tab for the column to be selected. Then I go to the last column being 2015 until 2020. I write 2015 until 2020 into quotes 2015. I select this one. You see, it is in any kind of quote, because if a column name is not underscored, you need to put it into quotes for a R to understand that it's a whole column name. Then, after specifying the columns to be transformed, I am going to name the resultant column. The resultant column is going to be names 2 will be time period. Let me call it time underscore period. Then value will be value 2 will be life expectancy. Life underscore expectancy. Then I run the function and see the results. After running the function, let me see the results. You see, we have country code, we have country name, we have the last dot observed. This column has not been touched, it's remained as it was. Then the time period, you see the time period here, you see the life expectancy here. We can even check if this has resulted the value that are reliable. Let me check for Afghanistan. The first value for Afghanistan. Let me sort this data set, the original data set, and check the value for Afghanistan A to Z. This is Afghanistan. The first value 1955 should be 2019.43. Let me check the resultant value here. Afghanistan should be, yes, for Excel it's quite correct. Let me check for Afghanistan here. You see, this is nice. 1950, 1955, 2019.43. It's okay. Now we can let me show you how you can produce this chart, the chart like this I created. How can you produce it in R? I showed you how you can produce in Excel. You see, this is the pivot longer I used within R. To do that case, I need to group by country name, grouping by country name, by countries. Then after grouping by countries, I select the first value, selecting or filtering filtering only the first value, using slice head. Because I have grouped but with country, the first value will be taken for each country. Then after doing it, I ungroup. Ungroup, why? Because if you group your data set before doing any additional data manipulation, you need to ungroup. If the data manipulation is not related to the grouping you have done before, you need to ungroup for the data set to not to behave in an unusual way. Because if you group and perform additional wrangling, you can have unexpected results pertaining to that grouping. Then after ungrouping, I arrange the values. I arrange the values with descending. I use the minus, or you can use descending like this. This descending can be used using this function. If you want to know more about this descending, you can access it like that. It's descending from this deploy R package. I then selected the first value can be selected, selecting the first 10 values, selecting the first 10 values or the highest countries with highest life expectancy. Those are the 10 values selected. Then I plot using ggplot. I reordered country names using this name, but we need to pay attention here. I had to reorder the country name by value, to reorder like this one, like what I did in Excel. I had to reorder this column, then this dataset had to be reordered. To understand it, if I reorder from smallest to highest, you see the chart is reordered as well. To achieve that, you can use this reorder within ggplot. If you can't do it like this, you can use mutate. You can reorder within mutate. I will show you in the next episode. After that, I use geom column. Let me run it and show you. You see, this is the chart. This is the chart I have reproduced from that one in Excel. This is ordered by smallest to largest. Let me order from largest to smallest. You see, I have here Norway with 74.6. If you want to, you want to add labeling here, you can click on this plus sign and click on this data labels. That is how we add labels within Excel. Then I add I can expand this to look much better. This is a chart, and this is the chart created within R. To know the code I used for color code, you see, I used the color code with numbers. For those who do not understand how I took the colors I used the image color pickers. Image color picker, this one, I had to take the chart I created within Excel, this one, the chart I created here, and I uploaded on this image color picker, and I clicked on these colors. If you click on color here, if I click here, you see I have the color code here. This color code, if I click here, you see the code has changed to FFF. If I click in blue color, the code has changed here. That is how I know which code to use, which color code to use in R. That is how I know which color code to use. I take a picture, I upload on the image color, I click on the color I want the code, then I copy the color code that image color picker has given me. That is how I tweaked everything. I had to use code Cartesian for limitation. You see, my chart here starts from 70 to 74. That is how I used coordination coordinates Cartesian, limitation of y-axis. I had also to use breaks on my y-axis. These breaks, I had to make it similar to this of Excel. You see, Excel has used from 70 to 75. I had to tweak everything in R to look similar to the chart from Excel. The only difference here, it is this title. I can add it here within labs, within this function lab. I can use title and write life expectancy like this one, and I run it. You see, the life expectancy here has now occurred. This is the chart now created. I think everything here is now similar to the creation in Excel. If you think you can achieve something within Excel, but you are not aware how you can do so within R, this is what we will be covering in this series of videos. This is the first episode. I will be updating you on new videos and how you can achieve different tasks within both Excel and R, so that anyone familiar with Excel can easily switch from Excel to R and can be more productive, because R, it's a code-based language. If whatever you have achieved now can be achieved easily in future by referring to your code. Let me thank you for today's session. See you in the next episode. Thank you. See you. May God bless you. Thank you.